Our censorship and propaganda video series teaches you how to identify and circumvent censorship and propaganda that costs you time, money, liberty, and sometimes your life, and find the products, services, leaders, and public policy that work better, cost less, and empower you. Evil Nerds. Should you trust the scientists? December 31st, 2021. In this video, I'm going to discuss whether you should trust scientists as a group, what is often today called the scientific consensus. I'm going to give three specific examples when the scientific consensus, or at least the opinion presented as fact of large numbers of scientists, was wrong, and raise the question of whether this was, quote, honest error or something worse. I'm also going to talk about that these are not just three rare examples, but there are many examples of this in health, medicine, biology, the study of human beings, many of the more difficult areas of science that are hard to do in a lab. Not physics, which I'm trained in, which also has cases of this, but I'm going to focus specifically on those that relate to public health and medicine. Should you trust the scientists? The three examples I'm going to give are specifically Pellagra, which is believed to be a vitamin deficiency disease that in the early 20th century ravaged the U.S., mostly the southern United States, and it mostly affected poor black people. It's not an isolated instance. Pellagra was incorrectly identified and believed to be an infectious disease that, strangely enough, only infected poor black people. Actually, there were some poor white people that were affected as well, but it mostly affected black people. It was incorrectly identified as an infectious disease. And I'll tell the story of it, but it's not an isolated incident. In the late 1800s, early 20th century, numerous vitamin deficiency diseases were misidentified as infectious diseases, such as things like scurvy, rickets, beriberi, and I believe some others. The role of nutrition was completely stomped out during this period by the medical and scientific establishment. Pellagra is not an isolated case. I'm going to talk about, in particular, the prefrontal lobotomy, which is part of psychosurgery. This is something that actually got the Nobel Prize and was widely practiced in the early 20th and mid-20th century. It went out of favor and became mostly discredited in the 1960s and 70s. For example, Rosemary Kennedy, one of the daughters of Joseph Kennedy, the sister of President Kennedy, was lobotomized. So this was something that people were really into, and it was done by wealthy families, all kinds of people. It was complete baloney. And finally, I'm going to focus on eugenics, which most people have probably heard of, and probably don't realize how many scientists, including nearly all the founders of modern statistics, used by essentially every field, and especially used in, for example, approving pharmaceuticals and claiming to know what's going on with viruses and vaccines, is all using the methodologies developed by these eugenics fanatics. I'm going to talk about these three cases. However, they are not isolated examples of this. There are many cases where there was overconfident belief in a medicine, in a medical treatment, in various other things. Again, these tend to happen in areas that it's very difficult to do highly controlled experiments like biology, healthcare, medicine. And these are all examples from that area. So pellagra was a disease which had been seen for some time, and it exploded for unclear reasons in the early 1900s. So let me explain. It's a vitamin deficiency disease caused by an absence of niacin, or vitamin B3. And in the early 1900s, it suddenly became much more common, primarily in the South and primarily among black people, although it affected other, poor whites, for example. But it was really hitting black people very hard, and it was incorrectly interpreted as a contagious disease. Even though when these people were brought to hospitals, the nurses, the doctors, and other people didn't get pellagra. They didn't catch it from the black people. And the way they got around that was to say, well, the black people have inferior genes, so, that's sort of how it worked. This was eventually shown over a period of decades to be false. And what really got it killed was that niacin was actually identified. The actual specific cause was found. Now, there were earlier experiments done on prisoners that strongly supported that it was nutritional. but it was actually a political football. There was all kinds of stuff that went on with it. It was widely believed incorrectly to be not a vitamin deficiency, but an infectious disease probably associated with moldy corn or things like that. This was one of a number of these vitamin deficiency diseases that struck Europe, the United States in the late 1800s. What is now thought to have happened with pellagra is that when we're talking about corn, most of these very poor people were eating cornmeal, which is highly processed. And what little niacin there is in corn, it has a very low amount of niacin, was largely removed from the cornmeal. So they had these cornmeal-rich diets. In the early 1900s, a new food processing method, the Biel degerminator, was introduced into making cornmeal, and this made this even worse. So it pushed things over the edge, and it removed what little niacin remained in the cornmeal, resulting in a sudden outbreak. Now, pasteurization of milk, for example, which is usually presented as a big leap forward attributed to Louis Pasteur in the late 1800s, produced an epidemic of rickets, of vitamin D deficiency. Nobody realized this was happening. Now, today, milk is fortified. They put the vitamin D back in it so this doesn't happen. But that also was blamed on a contagious infectious disease. The germ theory was in. It was the hot new thing in science and medicine in the late 1800s, early 20th century. All sorts of things were blamed on germs, on bacteria, and what became to become as viruses during this period in time. So large fractions of the scientific and medical community went right off the deep end, and they were grossly overconfident in their conclusions, either sincerely or they were understating the uncertainties which they actually knew were there, which is where we get to the notion that maybe there's some evil in this, people advancing their careers, political agendas. We'll see again and again in these cases that there's an underestimation, a gross underestimation of the uncertainties. The scientists make very confident statements about the cause of something or what's going on that really isn't justified by the evidence. And if they were doing their jobs well, in many of these cases, they would have presented much larger uncertainties than they did. Psychosurgery is notorious. There's an example of this in One Flew Over the Cuckoo's Nest, the book, and it became a Jack Nicholson movie, where one of the characters is lobotomized. But lobotomies were the in thing, the idea that you could actually fix schizophrenia, other mental illnesses, by cutting out actually what we now believe to be the part of the brain that is responsible for higher cognitive function, the prefrontal area, prefrontal cortex, which is removed by the lobotomy. And this character, Antonio Egas Moniz, got a Nobel Prize for this. This was widely embraced. It was nonsense. Peer review, scientific consensus, all that kind of stuff that you hear about did not work here, just as it did not work with pellagra and many of these vitamin deficiency diseases. And although I can't go into it in such a short presentation, there are many examples in medicine when people have been anywhere from grossly overconfident about a new medicine or medical procedure. Even if it worked, they went overboard with it. This happened with steroids, for example. They were either grossly overconfident or actually it was harmful, as prefrontal lobotomies almost certainly are. And I'm going to conclude by talking about eugenics, which is probably one of the most notorious examples of a scientific consensus that was largely political and ideological in its origins. And this was embraced. People tend not to realize this. In the 19th century, the early 20th century, this was very widely embraced. I'm going to focus especially on its close connections to statistics and the development of modern statistical methods that are used to purport to show the safety and effectiveness of vaccines, drugs like Vioxx, for example, and many other. These methods are used in every scientific field. So eugenics was the idea that basically our cognitive function, our intelligence, our temperament is exclusively or mostly determined by genetic inheritance. And it was very popular with the elite, the Anglo-Saxon elite in particular in England in the heyday of the British Empire, the Victorian and Edwardian era. I'm going to talk mostly about that, but also here in the United States. And it was widely embraced by scientists, and it was widely embraced across the political spectrum of that time. So so-called progressives and socialists, people like H.G. Wells, who was a Fabian socialist, George Bernard Shaw, There are many examples of people you might think of as, quote, the left of the time, or the progressive movement, which is a complicated entity in this period of time. It's not a pseudonym for socialist at that time. Many people embraced this. It led to policies and laws in several states in the U.S., here in California, for example, and also in the Scandinavian countries like Sweden, to sterilize people who were supposedly mentally unfit or otherwise defective. And this was done to tens of thousands of people. And it's generally credited with contributing to the extreme sort of eugenics philosophy and atrocities of the Nazis. And that's actually what it did in eugenics. So it became very anathema. So eugenics was heavily promoted and is mostly traced to Francis Galton, the cousin of Charles Darwin. And he applied Darwin's ideas to heredity. And he actually wrote a book called Hereditary Genius, in which he argued, often using examples from his family, the extremely wealthy and powerful Darwin-Wedgwood clan, of which both he and his cousin were part of, saying, you know, my family is full of great scientists, political figures, lawyers, you know, anything, you name it. And he argued this was genetic in basis. You know, in other words, these guys were finding that they had better genes than everybody else. And this book got a lot of pushback. A lot of people came back and said, wait. Your family is like one of the wealthiest families in the British Empire. You go to all the top schools, to Eton, to Harrows, to these, you know, private schools for the rich. You have all these advantages. So how can you argue that? And so he moved into developing statistical methods, and he funded Carl Pearson and other people. He funded the statistics movement. He and other members of the Darwin-Wedgwood family, Darwin's family, they funded statistics, the development of statistical methods, specifically to prove and promote eugenics. That was the goal. Not surprisingly, these guys he funded kept producing studies showing that eugenics was the right idea, that there was, you know, your intelligence was hereditary, all this kind of stuff. They went clearly beyond what they could actually tell. Again, there's this overconfidence, this understatement of the uncertainties. And so let's be clear, it's actually very difficult to separate hereditary intelligence, for example, from environment. Why is that? Well, let's say two things. Let's say intelligence or other cognitive abilities translate into success, right? Well, those successful people will almost certainly invest their money in educating their kids and in training their kids and passing on the knowledge they have, right? That's what they're going to do. That's what you logically do. You take care of your kids. So now we have a problem. The successful pay for their kids to go to Eton, go to Oxford and Cambridge, to have special tutors, whatever it takes to give them the best, right? That's what people do. So how do you separate out the fact they have a lot of money from this environment? This is a persistent problem that exists to this day. It's very difficult in practice to separate heredity from environment. And that even applies to things like adoptions, because typically when people put up their kids for adoption for some reason, they're trying to get the best for those kids. They're trying to get very frequently people from the same group. Catholics will often go through Catholic adoption agencies to send their kids to other Catholics or any other group, Jews or wealthy people, etc. So it's very hard to do a controlled blind experiment, even on things like adoptions of identical twins, which probably in theory would be your best test, although there's some issues there as well. And also one of the issues that you have is there could be something anomalous about twins, identical twins. There aren't very many identical twins either in the world. I mean, it's a very rare thing to be born an identical twin, so you don't have very good numbers, statistics in that sense. So Francis Galton funded Carl Pearson and his research group in England and many other people. Now what happened, and this is important to the sort of passing the buck for eugenics to a scapegoat, to one person if possible, is Leonard Darwin, the son of Charles Darwin, is a major force in funding the eugenics movement other than Francis Galton. So several members of the Darwin-Wedgwood family were funding this movement. It wasn't just Francis Galton. Darwin became friends with the then young Ronald Fisher and backed his research. He provided money and connections and so forth. And Fisher revolutionized statistics. He brought in methods from astronomy, where there was very advanced statistics, into statistics. Those methods have spread and evolved into the statistical methods used in pharmaceuticals, in verifying the safety and efficacy of drugs, of vaccines, and many other fields. In experimental particle physics or high energy physics, the methods that were used there that I used in my PhD thesis and many, many other people in that field use, they're all, most all from Fisher and his colleagues, but mostly Fisher. Fisher was the driver. In his 20s and 30s, he was very productive, and he revolutionized the field, and most of his colleagues he got into fights with. Most of them were maybe jealous. He got into a fight with Carl Pearson and his son Egon Pearson and so on. There was enormous hatred of Ronald Fisher. Now, he was a difficult person by most accounts to deal with, but it's not all his fault. So these guys got into this terrible feud. They were all eugenics fanatics. They were all into this stuff. But in later years, Fisher would get disproportionately heavily blamed for the eugenics. This is one of the ways in which these fiascos in the history of science, in which actually a large community of scientists standardized something and were clearly grossly overconfident of their interpretation of the data they actually had, there's often a scapegoating process where one person or a small subset of the people who were wrong or overconfident, we'll say, reported uncertainties far smaller than they actually were dealing with, gets blamed if they have to explain how this fiasco happened. And that's part of how the process keeps repeating generation after generation after generation. Okay, so why is it we don't learn from this experience to be more cautious about scientific consensus, or all the scientists say this, or at least all the reputable scientists funded by the Darwin-Wedgwood family or the Rockefellers or the other people that bankrolled the eugenics movement? Why don't we learn from that? Or government agencies, as is the case today. So I've shown you 3 examples. Eugenics is probably the most notorious, right, of cases where there was a scientific, this is not one scientist or a couple guys off in some little lab somewhere, off in their own little world, who went over the deep end, right, were way wrong. These are actually large communities of people. These were the orthodoxy for anywhere from a period of several years to decades, often generations. Eugenics really cratered after World War II. The Nazi atrocities, the Nuremberg trials, all this kind of stuff, it completely tanked. Many of the eugenics organizations disbanded. They changed their names. Many of them repurposed themselves as like reproductive health, population, other things. Eugenics was just, everyone distanced themselves from it to a very large extent. So why don't we learn from this history of many cases like this? This is just the tip of an iceberg, particularly in areas like biology, health, medicine. Well, first of all, they're rarely mentioned. If you read a typical textbook or popular science account, these things are frequently not even mentioned at all, or failing that, they're very minimized in terms of what actually happened. The number of people involved, it's presented as an aberration by one or a few kooks. In statistics, we see this with the demonization of Ronald Fisher, and to some degree Carl Pearson for people that dig deeper. But this was really central. I mean, again, the Darwin-Wedgwood family, these people who were into eugenics were funding the whole effort specifically to sell eugenics. Right. There was at least an ideological agenda, maybe an economic agenda that we don't fully understand, related to the British Empire and its politics. So minimize, blame a scapegoat or a few people. Oh, that was that weirdo guy and nobody else believed him. That's very common. But then the question is, how does this happen? And in fact, it's a lot of people in many of these cases. It becomes the hot thing. The germ theory was the hot theory in the late 1800s, the early 20th century, in some ways even today. But especially at that point, people were just blaming everything on germs. That was the cause, right? Or other parasitic organisms. So, for example, there was a Nobel Prize for a theory that certain types of worms were causing cancer. So at one point, that was very hot. How are these things explained? Obviously, there are things like bias, error, incompetence. What we can see over and over again in these cases is excessive confidence, allegedly very small uncertainties. These things are presented as like, we've done the research, we know the answer, it's settled science, that's what you'll hear today, that kind of thing. You know, we know this, couldn't be wrong. They're far more confident than they in fact should be in case after case. Is that just error, bias, incompetence? Certainly that probably accounts for some of it. we also have to consider maybe these people are ambitious, power hungry, have hidden agendas, as may very well have been the case in eugenics, for example. There are economic and political reasons that it might have been better to blame pellagra on an infectious disease that sort of picked on black people than, for example, to recognize that it was a symptom of general malnutrition and poverty, primarily in the South, as it happens. But there was an agenda there where it may have been much more appealing to blame it on a contagious disease than on economic conditions, on environmental factors that were subject to public policy, for example. Evil nerds. Scientists can collectively, as groups, make large mistakes or perhaps intentional false claims. There is a substantial history of this, especially in medicine, health, biology, and other areas which are technically challenging. It's very hard to do the idealized, controlled experiments that have historically, especially in the 19th century, could be done with tabletop physics, things like electricity, your iPhone, again, chemistry, some areas of chemistry. These can be done in a very controlled way, partly because you're not experimenting on people, where there's various ethical issues and people are complicated. There's a long history of being wrong and a long history of the scientists being grossly overconfident, either sincerely because of bias and confirmation bias, all these kind of psychological effects, but it can be just fraud. It can just be that these people are being dishonest and pursuing an agenda. High intelligence, being really smart, which many of these scientists probably were, doesn't make you a good person. It's not moral character. And again, we respond overly positively to confidence in people. People who claim there's no uncertainty, they know what they're doing, we collect to them. And therefore, to advance your career, to make a lot of money, to get grant money, all these kind of motives exist to overstate the certainty, to claim a very small or no significant errors in claims. That's what happened over and over again. Now, we don't know the motive. We can't read people's minds in most cases. But understand, there's sinister motives behind why you would do this. There's selfish motives behind why people would do this, especially in something as important as health and medicine, where people spend literally trillions of dollars on major medical problems. So should you trust the scientists? No. Even if they all appear to say the same thing and they're very confident, etc., you need to verify. You need to drill down into the facts, the substance, ask hard questions, and don't accept the kind of excuses that are given, some of which I've touched on here, for these failures. Our censored search website and service enables you to search censored and shadow banned websites for suppressed information. We offer transparency on what the search ranking algorithms are doing and tools to help you separate fact from disinformation. We offer both a free service for everyone and a paid professional service with full access to our tools and the ability to customize the search algorithms for your needs. Our business model is end-user funded to avoid either direct control or subconscious bias from advertisers. Our censored search service is intended as a complement to increasingly censored advertising-funded search engines, such as Google, Yahoo, Bing, and even DuckDuckGo, which appears to be increasingly shadow banning alternative content. We cannot duplicate many useful features of the advertising-funded search engines yet, nor is this needed. Use our search engine for censored and shadow-banned content. Get the other side or sides of the story. Remember, there are often more than two sides to a story. Inclusion in our search engine is not an endorsement. We include sites based on evidence of censorship or shadow banning in our judgment. We attempt to be neutral and provide tools to our users to evaluate and verify the content without relying on our fallible judgment. There is evidence that powerful interests actively spread disinformation to alternative sites to make identifying suppressed factual information difficult and discredit factual information through guilt by association. We are developing tools to fight these active disinformation tactics. Give us a try at censored-search.com, censored-search.net, or censored-search.org. We welcome constructive feedback. How can we serve you better? Bookmark our site as the censorship is growing by leaps and bounds. You may need us more in the future. Let your friends and colleagues know. You can access more advanced features and support development of a transparent, verifiable search engine that works for you and not giant advertisers such as Big Pharma by becoming a paid subscriber. If you want to support our development work, subscribe now. This concludes this video presentation. If you like this video, please click like. Please click subscribe and the notification bell if you would like to receive more content from us. You can avoid internet censorship by subscribing directly to our RSS news feed. Please consider sharing the link by email and on your website or blog, in addition to liking, upvoting, or sharing on increasingly censored, advertising beholden, big company social media. We have encountered such censorship. Mathematical software is developing algorithms and software to automate data analysis, reducing the risks of costly errors and increasing the predictive power of the results. You can support our work financially by subscribing on our Patreon page, https://www.patreon.com/mathsoft, or scanning the QR code in the lower right corner.